Okay, so we've been talking about material balances on single units or multiple units. We're going to add just one level of complexity next. We want to talk about recycle and bypass. So normally we have something where maybe we have a feed and there's one process, possibly multiple processes, and then there's a product coming out. Perhaps multiple products also. What we want to add to this is the idea of recycle or bypass. Now, more common is the recycle stream, where I have feed coming in, goes through the process, and comes out, but I'm going to withdraw a small portion of this product and return it to the feed. Okay? If I do that, I might draw an arrow here indicating that this is a recycle stream, that the flow is going in this direction. Now, recycle streams are going to be most commonly used when I'm talking about catalyst recovery. Remember, a catalyst is used in a reaction but not consumed. And so maybe I don't want to waste that catalyst, so I'm going to return it back into the reactor. Or maybe I want to make sure that the process stream is adequately dilute to get the right kind of reaction rate I'm looking for. And so I might send a recycle back that way. I'll also do these for control. And then just to keep things moving, maybe I'm circulating a fluid through here just to keep things well agitated, well mixed. Now a bypass stream is going to do sort of the opposite. I have most of my material going all the way through the process, but I'm going to maybe withdraw some of it in the feed and take it and skip the process and mix it into the product. This would be commonly done. Maybe you have a heat exchanger here as your process, and so the material is being heated. But in order to control the temperature here, you can't change the size of the heat exchanger, but you can take some of the cool material and bring it over here and cool this just a little bit if it got heated too much inside my exchanger. So we might use this as a bypass, typically for control scenarios. Analyzing these requires me to look at those two special spots where I either split the stream or mix the stream. Okay? Now let's look at the split points first. The easiest thing to do is to simply take my streams, okay, that are drawn as little lines with arrows, and block out as if there was a little unit there, a little invisible unit. So I have one stream in at the split point and two or more streams out at the split point. Now, since all it is basically piping, the composition in the feed will be the same as what comes out of this little split point unit. And the material balance is really easy because nothing will be accumulated, generated, etc. And so therefore N will equal the sum of everything coming out. Mixing points are, depending on your point of view, either easier or more difficult because although I have N equals out, I don't get the advantage of knowing what's in all the streams. Okay? So I don't have any additional facts. Right, if this were pure water and this is pure H2SO4, then this is going to be some sort of weak acid solution coming out, depending on what the flow rates of these two streams are. So I'm not going to really know anything compositionally about mixing points, but split points I have great information because the composition is the same on all of those. So I want to just talk briefly about an example. So this is the words for the problem. I'll get to the picture in a moment. I have, in this example, we're going to be working in the next video, 100 kilograms of a wet material. So maybe you did your laundry, okay, and it's wanting to be dried from a moisture content of 15% water to 7% water. So we want to figure out how much water is going to be removed. We want to figure out how much dry air needs to be fed in, and then how much dry air is going to be recycled. Now you say, this doesn't say anything about recycle. Well, that's why we need it. So the diagram shows that my wet material is going through. I have fresh air flowing in, and leaving, but I'm going to be recycling some of this air to keep an adequate flow rate going in there. Okay, now unfortunately air always contains water, and so the moisture information about these streams is given below. Okay, so it comes in fresh, containing 0.01 kilograms of water per kilogram of dry air. Okay, that's the air without the water in it. And it's going to go into the dryer with 0.03 kilograms of water per kilogram of dry air. And the recycle stream contains 0.1 kilogram of water per kilogram of dry air. So in the next video, we're going to look at how to solve this problem. So I would really like it if you would take a moment to try this on your own, see how you do it solving it, and in the next video, as I say, we will look at the solution.